Hello again. Another video in carbon chemistry. This time it's number 3, the alkenes. So you just watched, or we previously watched, the alkanes. Now we're going to do the alkenes. And this group is our first group of unsaturated hydrocarbons. What does that mean? Well, they're unsaturated because they contain at least one double bond between the carbon atoms. Okay, and in physical science we're pretty much only going to deal with one double bond in the chain. No matter how long the chain is, we're only going to put one double bond in there. And their names end in "ene", and they have the general formula, which is a little bit different from the alkanes. CnH2n. Okay, slightly different from the alkenes. Again, that's on your information sheet. And however, they are also a homologous series in that they have consistent changes in their properties as the carbon chains get longer and longer. And here's a couple of examples. Propene, and there's our double bond. There's a chain of 3 carbons. So notice that this carbon only has one hydrogen coming off it. That's because it's got a double bond there. But if we count the number of bonds on that carbon, it's still got 4 bonds, so it's happy. And this carbon as well, previously the end carbons have all had 3 hydrogens coming off it. This one only has 2 because it's got that double bond there. So if we count the hydrogens coming off that carbon, we count the covalent bonds, we get 4. And so whenever we're drawing these molecules, we've got to make sure each carbon has its 4 bonds. And this is one called but2ene, and this is a chain of 4 carbons with a double bond between the 2 middle carbons. And this number here tells us where the carbon bond, the double carbon bond, is, because this carbon bond could have been there or could have been there, and it has a very different name depending on where the carbon double bond is. And that's part of the naming rules, which I keep promising we'll get to, and we will eventually. You'll learn once we get to that section. So notice also they've drawn the hydrogen down here and this hydrogen up here. You could have just as equally put the hydrogen there or there, swapped it over, because what we're drawing here is a 2-dimensional representation of what is effectively a 3-dimensional molecule. So we're making compromises whilst we're drawing it, so we can do that. And typically the carbons don't form a straight line, they form a zigzag, but it becomes a bit neater if we draw it as a straight line. The alkenes undergo combustion reactions with oxygen and produce carbon dioxide and water, and looks very similar to the reaction with the alkanes. Again, you just have to balance it. And they react with hydrogen or the halogens. Now the halogens are the group 7 elements, the fluorine, the chlorine, the bromine, and they undergo what's called an addition reaction. Now we're contrasting that with a substitution reaction. And I use the analogy in substitution, like a footballer going on. To get onto the field, someone has to come off. Excuse me. An addition reaction is like someone was cheating and they just snuck an extra player on without one coming off, basically. Now they're only able to do this, the alkenes are only able to do addition reactions because the double bond is broken. And instead of having a double bond, one of those bonds breaks. So think in terms of the electrons becoming free to bond with the hydrogens. And so you just end up with a single bond rather than a double bond, and the hydrogen or the halogen, the chlorine, fluorine, bromine, then bonds onto those free electrons that are sitting there. So when chlorine is added to ethene in the presence of a catalyst, so this is an example, so here we have our double bond, we've drawn our formula correctly, we've got our chlorine. Now catalyst is just something that speeds up the reaction but doesn't take part in the reaction. We've come across those before. This double bond breaks. The one electron swings around to here and one electron swings around to there, and then the chlorine can jump onto it. And if I was to draw that, let's see if the drawing apparatus works. Where's my pen? Come on. Doesn't want to work. Here we go. So if we break that bond there, one of the electrons moves around to here, and the other electron moves around to here, okay, and that allows the chlorine, which effectively has 2 electrons there and 2 electrons there, to form the covalent bond. And that's what I'm trying to say there. And let's just get rid of that and get back to this. So also, alkenes can undergo what's called self-addition. That sounds interesting. And that's where alkene molecules join together to form long chains called polymers. And we'll have a separate video on how that happens. And so we won't talk about it now. So you should be able to do these questions out of your textbook. No major problems there, hopefully, and they would have been the answers. And we'll put on a video about the alkenes that just reinforces what I've just been saying. And the next video will be our third and last of the hydrocarbon groups, the alkynes. So cheerio.